Homework from Wednesday. So a fair coin is flipped and an unbiased die is rolled. Fill in the sample space below using heads, H for heads, T for tails, and numbers 1 to 6 for the dice. Okay. So this one here is going to be heads and a 1, heads and a 2, heads and a 3, heads and a 4, heads and a 5. Sorry, this is messy, but hopefully you can see it just about. Then tails 1, tails 2, tails 3, tails 4, tails 5, and tails 6 is done. So what is the total number of possible outcomes? So if you count up what I've just done there, we should get 12 outcomes. How many outcomes show a head and a 1? Well, there's just the first one there, so just 1. What is the probability of getting a head and a 1? So we said that happened once, so getting a head and a 1 happened once out of 12, remembering that probability has to be a fraction. How many outcomes show a tail and an even number? Okay, so a tail and an even number. So remember, even numbers are numbers that divide by 2. So there's a tail and an even number, there's a tail and an even number, and there's a tail and an even number. Okay, so there's 3 of them. And what is the probability? So once you see probability, you know you're going to have a fraction of a tail and an even number. Well, there was 3 of them out of 12. And if you simplify that to 1/4, that's fine. Okay, it's the first one. Right, a chef designs the following menu. So for starters, we have potato soup and garlic bread. And for mains, we have beef, chicken, and vegetarian quiche. Draw a tree diagram showing all the possible menu options. Okay, so we start with the seed, and starters comes first. There's 2 options for starters, so 2 options means 2 branches. So 1, 2, and we'll do P for potato soup and G for garlic bread. Okay, so that's your starter. After that, then they choose a main. There are 1, 2, 3 mains, which means 3 branches. So I do 1, 2, 3 branches here, and 1, 2, 3 branches here. So beef, chicken, and vegetarian quiche. Beef, chicken, and vegetarian quiche. Okay, then we have to go from here to each of our endpoints all the way down. Okay, so we have potato soup and beef. We have potato soup and chicken, and we have potato soup and the vegetarian quiche. We have garlic bread and beef, garlic bread and chicken, and garlic bread and the vegetarian quiche. So there's your options. To draw a tree diagram, show all the possible menu choices. Done. A food critic enters the restaurant and decides to pick at random from the menu. Find the probability that the critic picks soup for starter and beef for main. So how many times does that come up? Soup for starter and beef. So that there's potato soup and beef. So it only happens once. We're looking for a probability, so we need to make a fraction. So how many were there? 1, 2, 3, 4, 5, 6. So 1 out of 6 is the probability of the critic choosing soup and beef. What is the probability of him choosing garlic bread for starter and a meat dish for main course? Okay, so garlic bread for starter and a meat dish. So this is garlic bread and beef, so that's garlic and meat. This is garlic bread and chicken, so that's garlic and meat. This is garlic bread and vegetarian, so not that one. So there's 2 of them. So two possibilities for garlic bread and a meat out of 6, and that can be simplified to a third, but does not need to be. Okay. And a fair spinner, coloured red, green and blue, is spun twice. Using a tree diagram, list all the possible outcomes. Okay, so first spin, start with the seed. On the first spin, there are 3 options, so 3 branches. So 1, 2, 3, red, blue, green. On the second spin, it's the same spinner, so there's still 3 options. So 1, 2, 3, 1, 2, 3, 1, 2, 3. So red, blue, green, red, blue, green, red, blue, green. Okay, we'll do all our options. So the first one is red, red, second one is red, blue, then red, green. Now we move down to the blues. So blue, red, blue, 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 green, and then to green, red, green, blue, green, green. Right, find the probability that the spinner will land on red both times. So 2 reds. Only happens once. So that's once out of 1, 2, 3, 4, 5, 6, 7, 8, 9. Once out of 9. The probability the spinner will land on red and green in any order. Okay, so so here's red and green. And here's red and green. Yeah, they're in 2 different orders, but it said any order, so that's fine. So it happens twice out of a possible 9. The spinner lands on the same colour on both spins. So this is the same colour on both spins, red, red. This is the same colour on both spins, blue, blue. And this is the same colour on both spins, green, green. So that's 3 times out of 9, which again can be simplified to a third. And the spinner lands on different colours. Okay, so landing on different colours. Right, what have I not done? Black. So red and blue are different colours. Red and green are different colours. Red and red is not, that's why I skipped it. Red and red is the same colour. So blue and red are different colours. Blue and blue, that's the same. Blue and green are different. Green and red are different. Green and blue are different. Green and green are the same. So that is 1, 2, 3, 4, 5, that's 6 out of 9, which is simplified to 2/3. Okay, and that makes sense because the previous one was kind of the opposite of that. The previous one was the probability of the spinner landing on the same colour both times, and then this is the probability of the spinner landing on different colours. So it makes sense that they both add up to 1. Okay, this is 1/3, this is 2/3. If you add those two together, you get 1. So that makes sense. Alright, so that's the entire chapter on probability. So before we do a test or anything, I'm going to move on and do the second chapter, and I will test them both together. So check that homework, please. As always, correct it. So if there's anything that you have wrong, if you have it right, tick it. If you have it wrong, fix it. And then the important thing is that you understand what I've done, okay? If you don't understand it, you need to ask. Okay, we are moving on. Where is it? Yeah, here. All right, to chapter 1, which is sets. Okay, so you have some notes to take down here. So a set is a collection of well-defined and distinct objects. Okay, it says underneath here, well-defined, we mean that it must be clear which objects and elements are in the set. So if I said, we'll have examples of this here, but write the set of numbers between 1 and 10, including 1 and 10. That's very clear. If I said that to all of you, you would all write down the same numbers. If I told you to make a set containing the numbers between 1 and 10, including 1 and 10, you would all write down 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. That's what you'd all write down. Okay? Which makes it, where is it? Well-defined. Okay, it has to be well-defined, and well-defined means that when you describe your set, everybody would get the same thing. Let me give you an example of a not well-defined set. So if I said, write down the set of good TV shows. Now, if I said that to all of you in the class, would you all have the exact same list? Okay, if I said good TV shows. Okay, that is not well defined because my good TV show might not be your good TV show. And your good TV show might not be what the person beside you likes. Okay, so that's not a well-defined set. Okay, so that concept of well-defined is very, very important, okay? When you describe a set, you have to be very, very clear that everybody would write down the same list of numbers or letters or whatever it happens to be that you're listing, okay? So you need to take down the definition and you need to take down what well-defined means. Feel free to take down my examples if you want. So the bullet points down here, the elements or objects that make up a set can be anything. They can be numbers, letters, people, circle. We'll see that as we go through, okay? So it's not necessarily only numbers. It could be a list of TV shows, just not my example. It could be a list of colours. It could be a list of cars. It could be numbers. It could be letters. It could be shapes, okay? So it can be anything. The things in a set, so the things that make up a set are called elements. All right, so in my setup here at the top, each one of these numbers is an element in the set. Okay, the elements of a set are always placed within chain. They're called chain brackets, or sometimes called curly brackets. Now, students always find these really, really hard to draw. Okay, so I'm going to draw these for you. So when you draw a set, or when you write a set, you have to enclose them in special brackets called chain brackets, and this is how you do it, okay? So you go round, a little kick, and around, okay? And the same at the other end, except in the opposite direction. Okay, so that's a chain bracket or a curly bracket. Okay, see it? They take a little bit of practice, okay, but you need to persist because they have to be there. Okay, so they won't be perfect. I'm a bit funny writing them here on the tablet, but they won't be perfect, but you have to keep going. You can't enclose a set in a regular bracket like this. Okay, that's bad mathematical notation. You have to use these special brackets, okay, called chain brackets, but they're sometimes referred to as curly brackets. Okay, we use a capital letter to label a set. For example, the set of positive numbers less than 6 could be written as following. So if you're told that, let's say this setup here is the set B, you would say B equals. So you use a capital B is all they're saying. And when you're putting the elements in, you always separate them with commas. Okay, so there's a few little things about a set. So let's have a look. So which of the following are mathematical sets? So the subjects you study at school. So if I said the subject and I picked a person, so the subjects that, I don't know, Pat studies at school. Okay, if everybody was answering about Pat's subjects, everybody would get the same answer. Okay, so it's the subjects you study at school. So if you take it as you being the individual, and we were all going to write down what Pat studied, then that is a well-defined mathematical set. Okay, because it's your specific study. The days of the week, that's a bit easier. Is that a mathematical set? If I said, write down the days of the week, would you all write down the same thing? Hopefully. The days of the week are Monday, Tuesday, Wednesday, Thursday, Friday, Saturday, Sunday. Everybody would write that down. Now, the tall people in your class, is that a mathematical set? So hopefully you agree with me, it's not a mathematical set, because what's tall? So if we change that and we said the people in your class taller than 5'4", then that's absolutely a set, because that's specific. We measure everybody, we decide who's taller than 5'4" and who's smaller than 5'4", and then we have a proper, well-defined set. Okay, but just to say the tall people, it's too vague. It is not a mathematical set. The last one is similar, animals that run fast. So to say that animals that run fast, it's too vague. What does fast mean? Like, is fast a dog or is fast a cheetah? You know, what are we defining as fast there? Again, if you were to say animals that run faster than 20 kilometers per hour, that's different, okay? But to just say animals that run fast is too vague, so it would not be a mathematical set. Okay, so hopefully that makes sense. Now, a little example here. So what is a prime number? Okay, I think we came across this, it could have been the second years, I'm not sure. But a prime number is a number with only two factors, and those factors have to be itself and 1. So the way you might have learned it in primary school is that a number only divisible by itself and 1. Yeah? This is no longer the accepted definition for a prime number, but we'll talk about that in the next chapter when we're doing prime numbers. For here, for this, I just need you to understand what a prime number is, okay? So the proper definition that I'm going to need you to learn is this one here, but again, not particularly for this chapter, more for the next chapter. Okay, so it is a number that is divisible by only itself and 1. So let's look at B. Which of the following are prime? So 10. Okay, so 10 is 10 times 1, which is great. Are there any other options? Because if there are other options, it's not prime. So is there any other multiplication I can do to get 10? I can do 2 times 5. Okay, the fact that you can do 10 times 1, it is prime, but if you can do anything else, not prime. Okay, let's look at 11. So 11 is 11 times 1. Is there another option? There isn't. So that means 11 is prime. Now 12, okay, so 12 times 1, brilliant. Is there another option? Actually, I think there's 2 other options. 6 times 2 and 3 times 4, so definitely not prime. Okay, so A is the set of prime numbers between 2 and 13 inclusive. Now inclusive, you can see it here, means we include 2 and 13. List the elements of the set. So prime numbers between 2 and 13. Okay, so is 2 prime? So 2 is 2 times 1. Is there any other option? There isn't. So 2 is prime. 3 is prime. 4. Now 4 you can get using 2 by 2, so that means it's not. What about 5? 5 is only 5 times 1, so that's grand. 6 you can get 2 times 3, so that's not prime. 7 is 8. No, 4 times 2, so no, 8's not prime. What about 9? People always get this one wrong. 9 it can be 3 by 3, so it's not prime. 10 we did up here is not prime. 11 we did up here is prime. 12 is not prime. And then what about 13? 13 is prime. Okay, so they told me the set was A, so that's why I wrote A here. I listed all of my elements with a comma in between and I wrapped them up in my curly brackets. Okay, so that's a little introduction into sets. What is a good set? What is a well-defined set? And then if it is not well-defined and is not classed as a mathematical set. And then how do you write a set? Okay, so using the capital letter, using your curly or your chain brackets, and then listing everything with a comma in between. It is not necessary to list them in numerical order if they're numbers, or in alphabetical order if they're letters, but it's a nice way of doing it. It's easier to keep track. Okay, so while it is not necessarily required, I would urge you to do it. Okay, keep them in numerical order or alphabetical order. And right, that's it. So there's homework. This is the homework here. 2 little questions due for Monday. All right, so have a great weekend. Bye.